Hello, this is a demonstration of the Packet Radio Bulletin Board server that I made as my final class project for Professor Vahid's CS122A class at UCR. This project is a build upon my last project, where I used an MSP430 microcontroller to modulate AX.25 packets. In this project, I undertook the much more difficult task of demodulating packets and using that functionality to create a server that operates using amateur radio instead of the internet. Every step of the demodulation process is done digitally. This was a challenge due to the relatively weak processing power of the microcontroller. I chose a receive sampling rate of 9600 Hz as a trade-off between signal fidelity and processing time. To save as much processing time as possible, I implemented 16-bit fixed point arithmetic with a radix point at bit 14. To speed up multiplication, I wrote a function to directly access the hardware multiplier and grab only the higher result word. The signal path for the demodulation is shown as follows. First, the output of the microcontroller's ADC is sent through an IIR high-pass filter to remove its DC offset and center the signal around 0. IIR filters are used here because they generally require fewer coefficients than an FIR filter to achieve an acceptable frequency response. Next, the signal is fed into a mixer and delay queue. The delay queue delays the incoming signal by 4 samples before feeding it back into the mixer and mixing it with the current sample. At 1200 Hz, this delay is exactly 180 degrees, while at 2200 Hz, this delay is around 330 degrees. This means that the mixer output for 1200 Hz will always be negative, while the output at 2200 Hz will almost always be positive. After the mixer, the signal is fed through an IIR low-pass filter to remove higher-order frequency components. Following this, it is fed into a comparator that simply outputs a 1 if the mixer output is negative and a 0 if the mixer output is positive. The output of this comparator is the final oversampled bit stream. After recovering the bit stream from the output signal, a digital phase-locked loop is used to recover the clock signal from the bit stream and correct for clock drift and jitter. The oversampled bit stream is sampled on each PLL pulse to finally yield the transmitted data. The process for encoding the bit stream is then reversed to return an AX.25 packet in ASCII format. To demonstrate the capabilities of this modem, I implemented a basic packet radio bulletin board server. Such a server is useful for communication with many users over a wide area in remote locations. Here, you can see some of the basic functionality of the server. Users can upload messages to be downloaded by the recipient at a later date. This server uses a stack to store messages to be forwarded to other users. All stored messages are saved in persistent memory, so no data is lost even if the server loses power. Additionally, users can also play a game of tic-tac-toe against one another using the server as a middleman. To communicate with the server, I wrote a Python script to implement the same modulation and demodulation routine as on the microcontroller. This was also useful for verifying that the demodulator worked before porting it to embedded C. Thanks for watching.